For my course project, I implemented a paper that improves word-to-vec, a popular word embedding, with subword information. For many NLP applications, it is important to have good representations of words in the vocabulary. However, representing words as one-hot encodings can be very expensive. For example, a corpus of 10,000 words will result in a huge sparse matrix of size 10,000 by 10,000. In addition, such representations take away the semantic and syntactic relationships among words. In 2013, Mikolov et al. Proposed a new word embedding with a reduced dimensionality and that learns relationship among words. This model is also known as word-to-vec. In their first paper, they proposed two models for training, CBOW, also known as continuous bag of words, and the skip-grant model. In essence, CBOW turns training into a single-class classification problem, predicting the center word based on the context words. On the other hand, skip-grant model turns the training into a multi-class classification problem, predicting the context words given the center word. The trained model performs well on semantic accuracy tests and exhibits interesting vector algebraic properties. For example, the vector of king minus the vector of man plus the vector of woman results in a word vector closest to the vector of queen. This property allows word2vec to perform well in human analogy tasks. As the atomic level of training is individual word in word2vec, it ignores the internal structure of words. In 2017, Bujanowski et al. Proposed an improvement on word2vec by training the model with n-gram subwords instead of individual words. This new model demonstrates an enhanced performance for morphologically rich languages, such as German and Russian and other vocabulary words. For my implementation, I have constructed a simple three-layer neural network, consisting of one input layer, one hidden layer, which contains the final subword embedding, and the output softmax layer. In order to first generate the subwords, special characters are added to the beginning and the end of a word in order to preserve special features such as prefixes and suffixes. Since subwords can greatly increase the size of the input, all subwords are hashed into a hashing upper bound in order to bound memory requirements. In this neural network, the vanilla softmax function layer is replaced by negative sampling, which samples the number of negatives for each positive sample. This implementation reduces the computational complexity and exhibits better performance. After training, the output layer is discarded and the hidden layer contains the final subword embedding. Then the word vector of an individual word is a summation of the vectors of its subwords. Here is a zoomed-in section of the TSNE visualization of my model trained on a limited dataset. As you can see, the model exhibits good syntactic accuracy but low semantic accuracy. Words with similar internal structures are clustered together, such as become, home, some, sometimes. However, words with similar meaning are far away. For example, the pair same and different and the pair I and they are far away. Even with limited training data, the model is familiar with different morphological features. This table displays my model's performance in word similarity tasks. While it underperforms the model trained by the authors, it is important to note that 50% of my dataset only contains about 48,000 unique words. In this table, we can again observe that a model trained on limited dataset can perform decently on infrequent words, as the model can quickly learn features of internal structures of words. We can also observe the increase in common word accuracy as the training data increases. In conclusion, word2vec trained with subwords improves accuracy for morphologically rich languages and rare words. And from my own experiment, well-performing word vectors can be computed on datasets of a restricted size and still work well on rare words. For future work, a hybrid training scheme can be implemented by training a word embedding along with the subword embedding to maximize both semantic and syntactic performance.